Hello all. Today I'm going to discuss regarding the topic implementation of machine learning algorithms in agriculture. So here in this research paper, so we are basically describing regarding the different types of machine learning algorithms which are used in agriculture, like weed detection or precision agriculture or crop yield prediction and so on. So here mostly I'll be discussing about the different types of machine learning learning types with its algorithms, and like we have given some input data which was taken from Kaggle and what was the output predicted for that input data in case of agriculture. So coming to the abstract of this research paper, so here basically we are implementing the machine learning in agriculture, which can help us to solve future food production and supply issues. And the primary goal is to predict the crop yield, production, detecting different types of weeds in the crop yield, and leaf disease detection, and also practicing the precision agriculture. So I'm going to discuss regarding all these subtopics in machine learning. And also we can achieve yield prediction, weed detection, disease detection, and precision agriculture by implementing different types of machine learning algorithms such as Naive Bayes algorithm, random forest algorithm, KNN, which is K nearest neighbor algorithm. Uh, we are also using the concept of decision trees in machine learning, and also the neural networks like convolutional neural networks, and so on. So which aids in addressing the global food shortage problem by increasing the crop yield prediction. So coming to the introduction of this topic, machine learning is an artificial intelligence application that enables systems to learn from vast amounts of data and solve some specific problems. It uses computer algorithms that automatically improve their efficiency through experience. This is the primary research area in which we are interested in resolving and identifying problems using the different machine learning algorithms. So here, if you can see the flow diagram, this is the basic flow of a machine learning algorithm. So basically, we will be taking a raw data. So in this project, while we are implementing, we have taken some raw data from Kaggle. Those are the raw inputs of data which has the different types of temperature, different types of humidity, different types of crops. So all these data, whichever needed for a crop yield or in agriculture. So we had varied it, and we have taken it from Kaggle, and we had given it as a raw data to our paper, like to our experiment. So here there will be a data collection system. So here we have used Kaggle as our data collection, and the raw data what we have taken from Kaggle is like whatever I've mentioned, which are related to the entries which are related to the agriculture. And so after collecting the raw data, we are pre-processing the data. So this is one of the important step in machine learning algorithms. Like we need to pre-process the data, and after pre-processing process the data, we will be getting a bunch of processed data where we need to have some training models to that particular bunch of data. After the training, we will be testing the model whether it's working as per our training or not. So if we are satisfied with the accuracy whatever it obtained, we will be deploy that particular model data, or else again we will be turning it back to the training model. We will again train the data, and we will again check the accuracy, and we will be deploying it. So this is the basic flow of a machine learning algorithm flow, which we have taken as an reference for our experiment. So coming to the different type of machine learning, we are having two different types of machine learnings, which is supervised machine learning and unsupervised machine learning. Coming to the supervised machine learning, supervised learning used label data to train the machine learning models. The outcome in label data is already known, like we'll be already knowing what will be the outcome, and as per that we'll be training our model. And the model's input and outputs only need to be mapped here. That's all. And the coming to the other type, which is unsupervised machine learning. Unsupervised learning is a type of machine learning in which computers are trained using unlabeled data. So without labels, data lacks a constant output variable. Here we don't know what will be the output will be. It will be just training the data on our logic, and we need to analyze the output at that particular time. So that is the reason why here the data lacks a constant output variable. So again, if you can see the picture here, the machine learning is classified into supervised and unsupervised. Again, the supervised is classified into two types, which is classification and regression. And unsupervised learning is classified to clustering. So this is all about the types of machine learning, which what we are using. And coming to the related works, what we have taken as a reference for our project, for our paper is the first one is the pre-season agriculture yield forecast. As we are working on a crop yield prediction, we have taken this as a reference. So basically, this particular pre-season agriculture yield forecast is a machine learning based system that uses data from multiple sources to forecast soybean yield before the growing season begins. Here, what they have done is like they have taken the different temperatures, the different humidity, the different climatic conditions, and they're also differentiating using whether it's a day, night, and based on different type of crops. So like they have what they have done is like they have compared all these particular constants for a particular soya bean yield to predict its particular yield, crop yield forecast. So we have taken one of the reference from that. And coming to the next one is like, as I have told, we are also seeing about the pests. So here, that is the reason why we have taken the detecting pest insects. This study focuses on precise agriculture and aims to investigate several deep learning models for recognizing insects in images. So here the images are given as an input to the system, and we will be writing some logic there. Based on that logic, it will be detecting the insects on a picture, whether the pests are present on the leaf or not. So it is carried out in the field of precision agriculture also. And coming to the next one, which is the intelligent harvesting techniques. Here we discuss how like we use like the use of smart harvesting devices reduce the amount of time and effort of the farmers that must put into harvesting their crops, basically. Yeah. So, and coming to the one of the most important algorithm in machine learning, which is the random forest, which is the oldest algorithm that we are practicing. So here the random forest is a classification technique composed of several different decision trees. So, basically, a group of decision trees form a random forest. So, when building each individual tree, it employs bagging and feature randomness to try to produce an uncorrelated forest of trees whose prediction by majority is more correct than that of any individual tree. So, basically, how it works is like the individual trees forms a decision tree, and the decision tree forms a random forest. Basically, this is the model what we follow in the for random forest implementation for machine learning in agriculture. Here we need traits that can at least partially be used in predictive analysis. There must be no connection between the different forest trees and, more importantly, the forecast that they offer. We used, as I've told earlier also, again here also we use the Kaggle training data set, which contains nitrogen data, potassium data, phosphorus data. Basically, whenever we deal with any agriculture related things, we will be connecting the NPK, which is nothing but the nitrogen, potassium, and phosphorus data. And also, apart to that, we are also taking temperature data, humidity data, pH data, and also the rainfall data on expecting the crop yield prediction in the precision agriculture. So, and the next algorithm, what I'm going to discuss is regarding the naive-Bayes algorithm in precision agriculture. So here you can see the formula for calculating the naive-Bayes theorem. P of A by B is equal to P of B by A into P of A divided by P of B. So here P of A by B is nothing but it is the probability that an event A will take place given the knowledge that the event B has already occurred or already taken place. And P of B by A is its vice versa. So basically, the Bayes theorem provides the foundation for the naive-Bayes algorithm, which is a probabilistic machine learning technique utilized in a wide variety of classification applications. Here, we must provide the input data set, and we must also categorize the data accordingly. So here, we must also look for the most recent data set by the training model, and we must perform the cross validation on the data, that is on the both training data set as well as also on the test data set. Finally, we must check the accuracy of the results on the both. So this is what all naive-Bayes theorem says. And the coming algorithm which I'm going to discuss is regarding the k nearest neighbor algorithms, same which is here, which is used in precision agriculture. So for the k nearest neighbor algorithms, here we need to provide the input data set. So we must use the ASM to select the best attributes for training data, such as the Gini index or the Gini ratio. Here, this particular Gini index and Gini ratio plays a most important role in calculating calculating the algorithm's prediction for KNN. And we must divide the massive data set into a smaller data sets here, and also we must go through the process again and again for each and every child node. We should send the entire result to the model so that it can be evaluated. Finally, we computed the dataset's performance evaluation. Now here we must provide the input data set, and we must read the k value of from its closest distance from the node and its test data as well. We must locate the k closest neighbor to the test data, whatever we have tested previously, and also we must go through the process again and again for each child node. And after completing of this process to test the particular data, we must apply the maximum label of class K. Finally, we compute the dataset's performance evaluation based on its accuracy, and we'll be let to know its precision. So here you can see the accuracy table of algorithms for precision agriculture. After performing all of these algorithms like random forest, naive Bayes, KNN, and decision tree, so these are the accuracy results out of which random forest stands. The KNN stands with the most like it comes in like random forest has the most accurate results, which is 0.98 like 0.98, which is approximately 98%. After that, the KNN got its most accuracy result, which is 98.17, which is a slight difference from random forest. After that, we got a good result from naive Bayes followed by decision tree. So based on our research, what we found is that random forest stands with a good accuracy in performing the precision agriculture using machine learning algorithms. Now, neural networks in weed detection, yield prediction, and leaf disease detection. So here, as we know that the CNN, which is the convolutional neural network, is a type of a neural network, and that is commonly used for the recognition and categorization of uh, images and objects. Like a CNN is used in the deep learning object recognition process. CNN makes use of an open source online dataset. The dataset also includes additional datasets, most notably our own, which helps to round up the collection. Following data collection, the dataset will be pre-processed to improve image quality, and also it reduces the alpha channel intensity in preparation for the next stage, which will involve data reading. The dataset will be divided into three sections. One is the train data, validation data, and the testing data. Classification techniques such as convolutional neural network will be used to generate a model using training data that can estimate paddy growth levels. This will be done so that the model can be created, and also the model will be followed by an evaluation using the precision, recall, and F-score metrics. We need all these three things to work on neural networks. So now I'm gonna show like the experiments and what are the results we got of weed detection, yield prediction, and leaf disease detection here. So basically, as you can see, for the disease detection, the input data what we will give to the system is nothing but a leaf which has some gray spots on it. So if that system detects those gray spots, it will be giving us output of this image stating that this is a diseased leaf. As you can see on the picture, you'll be finding some gray spots on the leaf, which that's the reason why it gives us an output stating that it's a diseased leaf. And here also you can see the leaf is not entirely green, but it doesn't have a gray spots on it. It's just ruined, like it just have a brown path, but it doesn't have a gray spots on it, due to which it's a healthy leaf. This is what the output we got from the system, wherever we have given the input data. And the code and the programming language what we use here is the Python. And for a weed detection also, if you can compare the first picture and the second picture, in the first picture, if you can see, there are no small leaves like weed leaves here. Like that is the reason why it is giving the output as it's not dogs. And you can see here it's having the dogs. Like here you can see the weeds, the small leaves between the plants. So this is how it is getting differentiated. And this is a graphical representation of a trained data and a validation data for a yield prediction. So coming to the conclusion and future work of our research paper, Following the necessary analysis on agricultural datasets using various machine learning algorithms, it is clear that the random forest algorithm provides the most accurate results with the highest accuracy in the precision agriculture application. The implementation of neural network yields the most accurate results in the application of leaf disease detection and yield prediction. So, and also the project's future work will be is to train the machine learning algorithms so that the output of agricultural applications does not have to be provided manually. Like uh, like the late the farmers can automatically, the new farmers in the sense this generation farmers can automatically understand the data and the things to the trained machine learning algorithms. Thank you.